Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Want to know how to take advantage of the onboard gesture sensor? Or do you want to know how to take advantage of the onboard light, humidity, temperature, and color sensor? That's what this third video is going to be about. So without further ado, let's get started. Hello everyone, my name is Thomas. And in this video, I'm going to be showing you how to take advantage of some basic onboard sensors, specifically the color sensor, which includes proximity, gesture, and light, along with the temperature and humidity sensor. So in the next two videos, I'm going to be covering how to access the onboard sensors and how you can use it to make your own application without any use of external sensors. So without any further delays, let's get into it. To get started, you will need a couple of libraries installed on your Arduino IDE. I've already covered all the libraries that will be required for this series in the very first TinyML kit video. But in short, for this particular video, we'll be requiring two libraries, one APDS9960 and the HTS221. The former being the color sensor library that also has functions for proximity, color, and gesture, while the latter being for the temperature and the humidity sensor. So you can access the libraries in Files, Examples, and you can find Arduino APDS9960 library with all the example codes. For this tutorial, I will be making use of the full example code, which covers all the functions that this particular library can do, particular sensor can do. In the beginning, we have a small description of all the things the library does. You can go through it on your own time. For now, I'll be skipping it. And the code is pretty straightforward. So initially, we'll include the Arduino APDS9960 library into the sketch. As you all are familiar with, the Arduino IDE has two main functions, the void setup function and the void loop function. The void setup function runs one time in the beginning of the script, while the void loop functions runs continuously until the microcontroller is switched off. So under the void setup function, we do a serial.begin to initialize the serial monitor, and we only begin the code if the serial monitor is open. That's what the line 21 says. Next, we will initialize the APDS sensor. So you do that using the APDS.begin function. For some reason, if your sensor isn't being initialized, error message gets printed into the serial monitor. Next, we are initializing the variables that are required in the sketch. So we initialize the proximity variable as 0. We initialize the R, G, and B as 0, which stands for red, green, and blue. And the last variable we'll be using here is the last update variable, which is just a timekeeping variable. So then we come to the void loop function, where there are three main things we'll be doing in the void loop function. The first one is the proximity. So if APDS.proximity available, we read the proximity sensor and save it into a variable called proximity. We'll come back to this variable later, but for now we're just saving it into this variable. Pretty simple. So the way to read the proximity value from the Arduino Nano 33BLE is just use the APDS library and call APDS.proximity available and read it using the read proximity function. Pretty simple, right? The next function in the while loop function is the APDS.gesture available. So again, similar to before, if APDS.gesture available, we read the gesture and we save it into a particular variable. Now we check this variable with the switch case function to check whether the indication is gesture up, gesture down, gesture left, or gesture right, and the corresponding message is printed on the serial monitor. The third function that is in the loop function is the APDS.color available. Again, pretty straightforward. APDS.readColor R, G, B, and it'll save the red values in the R variable, green values in the G variable, B values in the blue variable. And last, we're just printing all the values that we read from the previous three if ladders into a serial print statement here. So serial.print PR, which is equal to proximity, we're printing it in the next line. And serial.print RGB, we are printing R, G, and B values in the next line. And this happens every 100 milliseconds. Pretty straightforward code and very easy to adapt to any other larger projects. So as an added bonus, as an added feature, before I upload this code, I will make a slight modification to this code such a way that the code also takes advantage of the Arduino Nano 33's onboard RGB LEDs. So I will make a simple modification where if the proximity sensor detects something, the onboard red LED lights up, and if the proximity sensor doesn't detect anything, the onboard LED lights up green. The onboard RGB LED is connected to the Nano pin 22, 23, and 24. So you can easily take advantage of the onboard LEDs in your own projects as well. So to add it to the code, you can begin by defining the pins. So at the very top of the sketch, you can write #define, the LED color, and the pin number. So in this case, the red LED is connected to pin number 22. Similarly, you can write #define blue connected to 24 and #define green connected to 23. Once done, in your void setup function, you'll need to initialize the pins to output. To do so, type in pin mode red output. Similarly, you will have to do for blue and green as well. Once these two steps are over, you need to now digital write these pins to high and low depending on the scenario cases. So for this particular example, I'm just going to, as I mentioned before, I'm going to write for the proximity sensor. So instead of defining it right here, I will be defining at the place where we print the value so that it aligns with what the user sees from the microcontroller. So I'll write a simple if condition here. If proximity is greater than or equal to 200, digital write red high delay for 500 milliseconds so that the user can see the red LED turning on. And then digital write the LED off. This way I will make an else statement where if the proximity sensor is less than 200, it's red. So if the proximity sensor is greater than 200, the LED that should be turned on is green. So just change it to green. And if the proximity sensor is less than 200, then the LED that should be turned on is red. So I'll just copy the same code, paste it here, just fix up the indentation, and change the color to red. Once done, you can put your Nano 33 BLE into boot mode by double-clicking on the onboard button. Then go to Tools, wait for the port to load, and click on the port that the Nano is connected to. And then click Upload. Once the code is uploaded, go to Tools again, click on the COM port. The COM port resets because the Arduino comes out of programming mode, so you have to select the COM port again. Once done, you open Serial Monitor and the code starts executing. So as you can see, the PR is indicating the proximity, and the RGB indicates the red, green, and blue values, and the ambient environment. So when the RGB value is about 200, the onboard LED glows green, and when I bring my finger close to it, it turns red. The other particular feature for this sketch is the gesture sensor. So for this demonstration, I have removed the LED code since it is interfering with the timings. But from the example code, if you directly run it, you should be able to also use the gesture sensor to detect gestures. So for example, you can use the up gesture to detect up, and as you can see, it's pretty consistent in detecting the up gesture. Similarly, I can do down, right, and left. So this is how you take advantage of the onboard color sensor to use it as a proximity sensor, to use it as a gesture sensor, and to use it as a color sensor. In addition, you can also use it as a light sensor, which is basically detecting the intensity of the light, ambient light, which again constitutes of R, G, and B. So if you remove the color data, it'll basically be a light sensor. The next sensor I will be demonstrating is the inbuilt temperature and humidity sensor. So to access the example code for it, go to File, go to Examples, and go to the Arduino HTS221 and click on Read Sensors. Again, there is a small description on what the program actually does, and the code is relatively very simple. The code is again divided into void setup and void loop, as with all Arduino codes. And in void setup, you begin the serial monitor, check whether the serial monitor is open, begin the HTS sensor, and if it doesn't initialize for some reason, the serial monitor will display that it failed to initialize the sensor. Once it's initialized, it goes to the loop function where it reads the temperature using hts.readTemperature function, and it reads the humidity in hts.readHumidity function. Both of them read in the data type float. And then you can directly print the sensor values onto the serial monitor. So serial.print temperature is temperature in degrees C and humidity in percentages. So again, similar to before, put your Nano into the programming mode, go to Tools, Port, select the port, and upload the code. Once the upload is done, go to Tools, change the port to COM14 or whatever is detected, and open serial monitor as before. It reads the current temperature, current ambient temperature, and the current humidity. So this can easily be again turned into a project where the Nano 33 can be solely used to detect some ambient conditions of a particular environment without any use of an external temperature module, temperature and humidity module such as the DHT11. Pretty cool, right? So the new Nano 33 BLE, which again, remember, comes in the same form factor as the Arduino Nano, includes a whole host of sensors that you would normally require external sensors for. But since it's all built into the Nano 33 BLE, you can easily make a single board system and make a pretty powerful application out of the microcontroller. So in the next video, I will be covering how to take advantage of the inbuilt microphone, the onboard barometer for pressure sensor, and the onboard 9-axis IMU, which includes the 3-axis accelerometer, 3-axis gyroscope, and the 3-axis magnetometer. So that's it. Thank you for watching this video. Subscribe to RoboCraze, click on the bell icon so you won't miss the upcoming videos on the TinyML kit. Thank you for watching again, and have a good day.